Good day, everyone. In today's practical, we shall be looking at the different ways by which we can carry out a food test. That is how we can test for some classes of foods. So we're going to look at test for carbohydrates. We're going to look at a test for protein and test for fats and oil. So on test for carbohydrates, the first aspect we're going to look at test for reducing sugar. That is, how do we test for the presence of reducing sugar in a food item? What we are going to use, the first one we're going to carry out is described as a Benedict test. Benedict test, that is when we're going to use a Benedict solution. Benedict solution contains mainly copper sulfate. So how do we go about it? The simplest way, you take after you have taken your suspected reducing sugar, that is that food item that you want to test, you want to use to test for the presence of reducing sugar, preferably glucose. So you prepare a solution of it. So you add 2 centimeter cube of 0.1% of glucose solution into a test tube. You add an equal amount, that is the same 2 centimeter cube of Benedict solution. You add it to the glucose solution, then you shake and boil the mixture. The mixture is likely to pump violently during eating, so you have to be extra careful when you are boiling. What you are likely to observe: the initial blue color of the mixture will turn to green, later to yellow, to orange, then to brick red color, which is the final the color you are going to see. And that brick red color is going to be a precipitate. So we refer to that as brick red precipitate. The amount of the precipitate that is present or that you see or observe gives a rough indication of the amount of reducing sugars that are present in that particular food item. That is, if the reducing sugar is present in large quantity, the precipitate is likely to be, to be more, or in large quantity also. Then you can also test for reducing sugar by using Fehling solution. That one is described as Fehling solution test. You place the small quantity, about 10 centimeter cube of a complex sugar. In this case, you add dilute hydrochloric acid. It's a complex sugar. So when we add dilute hydrochloric acid, we're adding dilute hydrochloric acid to hydrolyze the complex sugar. Place in a boiling water bath. That is, this you don't boil directly, you don't place the boiling tube or the test tube, you don't place it directly to the direct fire, but you place it in a water bath. A water bath, that is, you have something we refer to as water bath. We put water there. So while the water is boiling on the gas, you place the test tube in water bath, that is containing boiling water. Then you add dilute sodium hydroxide. The dilute sodium hydroxide is being added to to neutralize the acidic effect of the hydrochloric acid. Then later you add Fehling solutions A and B in equal percentage. That is, if you are adding 10 centimeter cube of Fehling solution A, you add the same 10 centimeter cube of Fehling solution B. But Fehling solution A will first of all be added to the to the solution, then later Fehling solution B. You are going to get orange red precipitate, which indicates the presence of reducing sugar. Then another test for carbohydrate that we normally carry out is test for starch. Starch is also a complex sugar. So what we normally use to test for the presence of starch in a carbohydrate is iodine solution. So Starch is only slightly soluble in water and it forms, a colloidal solution in water. Whereas starch, is a mixture of polysaccharides, that is something like amylose and amylopectin. So you prepare a mixture of starch, like the dry starch that we normally buy when we want to, we want to starch our clothes. You can get that one, or in another way you can get something like yam, any food item that usually perceive as if you have a large quantity of starch. So you can grind this one, you grind it into powder form, make a solution of this. It could be, it could be yam, it could be your yam flour, it could be cassava or cassava flour or potato flour. You make a solution of this. Or better still, you may not even prepare a mixture or a solution of this food item. You can add directly. But if you prepare the solution, you add about 2 centimeter cube of 1% starch solution into a test tube. That is, after you have prepared the solution of starch, you now take 2 centimeter cube of this starch solution, you put in a test tube. Then you add few drops of iodine solution. You are going to observe a blue-black color, which indicates the presence of starch. Now, like I said the other time, you may not even prepare a solution. You can also test for starch by using maybe a yam, cassava, potato. You just peel, you remove the cover, you remove the peel, you cut it open. After you have cut it open, you put 1 or 2 drops, few drops of iodine solution on the surface, and it changes to blue-black. Immediately it shows that starch is present. Now, test for protein. The first test of protein we're going to consider is Burette test. In Burette test, you use any protein, any food item that is, that we normally refer to as containing a large quantity of protein, like egg albumin or milk or meat or maybe fish. You make a solution of it. If you are using egg albumin, you remove it carefully in such a way that the yolk will not be added. If it is meat, you have to grind it, or fish, you grind it into powder and you prepare a solution of this. Now add 2 centimeter cube of this protein solution that you have prepared. You put it in a test tube. Then you add an equal volume of 5%, that is the volume of the protein solution that is inside the test tube. You add that same volume of sodium hydroxide to the protein solution and you mix. Then you add 2 drops of 1% copper sulfate solution. Then you mix or shake well. A violet color will appear, and this shows that protein is present. Burette reagents can be used directly for detecting the presence of protein without eating. Sometimes you may not need to eat. Most times you don't eat when you are carrying out a Burette test using Burette reagents. Now, we can also test for protein by following or using Millions test. In Millions test, we just simply use Millions reagents. You place your proteinous item such as egg albumin in a test tube. Then you just add few drops of Millions reagent. Thereafter, a deep red color or precipitate appears, and this shows the presence of a protein in the food item. Then the next one is a test for fats and oil. In test for fats and oil, we have the first test that we refer to as translucent spot test. What you do in this one, we take the food item, place it between folds of filter paper. That is, you place it, in between. You fold the filter paper and you place the food item in between it. Most times you use things like granules. Then you rub it or you press it. When you rub it for some time, or press it, you will see presence of translucent spots on the filter paper. Sometimes if filter paper is not available, we use a white paper, and when you press it, you see that the paper becomes translucent. What this one is saying is that the observation is confirming the presence of fat in such a food stuff. You can also test for the presence of fats and oil in a food item by carrying out what we refer to as a Sudan 3 solution. In most cases, we use when we want to carry out Sudan 3 test using Sudan 3 solution, we use oil. So you take a clean, dry test tube, place your few drops of oil inside the test tube, and you add few drops, maybe like 6 or 5 drops of Sudan 3 to the reagent. You do for to add drops, you may add with you may use a dropper. Then stir the test tube continuously, and you allow the solution to stand for a while. After after few seconds, you observe the changes, and you will see that the solution will have changed to pink color, and this pink color shows that, or pink color droplets shows that fat and oil is present in the food item. It is important for us to note that all the foods contain all the classes of foods. That is, they all contain carbohydrates, protein, fat and oil, water, and all this, but they contain them in different proportion. So what we are trying to say is that when you talk about a carbohydrate food, yam for example, does not mean that protein is not present, but is present in a minimal quantity. Fat and oil present there, but in a minimal quantity. So it is in foods item that you have a larger quantity of a particular class of food that you test for the presence of that particular food. Like for example, when we test for the presence of a carbohydrate or starch in yam, we're testing for that because starch or carbohydrate has a higher percentage than in yam than other classes of food. So these are the different ways by which we try to test for the presence of different classes of food in our food items. Thank you.